mathsers, hope you've had a lovely weekend. We're back to maths, we're back to fractions. So let's get our thinking caps on and start today's lesson. Looking at last week's lessons, this is your do it answers. Some of them can be simplified, for example 2 and 9/12 could be 2 and 3/4. The rest of them are as simple as they can be. Give your work a tick and let's move on to our twist. In this example, Colin has remembered the whole numbers in the answer, so he's remembered that there's 2 in the second part of the addition, but he hasn't made the proper fractions into equivalent fractions to add them correctly. Remember, they have to have the same denominator to be able to add them correctly. Instead, he's added the numerators. 2 add 3 is 5, and the denominators 3 plus 7 is 10. And on the twist it, the answer was sometimes the answer can be simplified in this calculation, and this is taken straight from Friday's Do It. So the example 2 slides ago, where we could simplify 9/12 into 3/4. However, this example cannot be simplified in this calculation. So 1/12 is in its simplest form, so you can't always simplify it. So moving on to today's lesson, start with our hook it. Right here we have an example of triangles in halves. We've got one whole triangle and, I'm just going to change the pen, we've also got an extra half a triangle. As a mixed number we could write that as 1.5, or we could count it as 1, 2, 3, 3 halves, 3 parts of 2. And we can convert between those. 1 times 2 is 2, plus the 1 is 3 halves. And in example B, we've got 3 whole ones plus an extra quarter, and that's how we'd write it as a mixed number. Or we could write it as an improper fraction: 4, 8, 12, 13, 13 quarters. And again, we could convert between those by doing 3 times 4 is 12, plus 1 more quarter is 13 quarters. And this final one here is split into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So we've got 8s here. We could say we've got 3 wholes and plus another 1, 2, 3, 3 eighths. And to work that out as an improper fraction, we could count in 8s, 8, 16, 24, plus the extra 3, 24, 25, 26, 27. So we've got 27 eighths. Let's get that written down. So these improper fractions are all equivalent. We can put an equal sign between them. They're all equivalent. And to convert between them, you can draw them out, or you can use your multiplication and division to work between them. And in today's lesson, you might need to be able to do that, and I'll put a link on Class Dojo to help you to convert between them. So today our lesson is to add mixed number fractions. Let's recap. How can we change these mixed numbers into improper fractions? We looked at the drawings before. We've got 3 whole ones and 2 fifths. Now each of these whole ones, we can imagine, could be split into 5 equal pieces. So 1 whole is the same as 5 fifths. Okay, so if we have 1 whole, that's 5 fifths. 2 wholes would be 10 fifths, and 3 wholes would be 15 fifths, plus an extra 2, and that gives us 17 fifths. So we can use our times tables to work those out. In this second example, we've got 2 whole ones, but they're split into quarters. So in each whole, we've got 4 quarters. So in 1 whole one, there's 4 quarters, 2 whole ones, there's 8 quarters, but there'll also be the extra 3 here. So 8, 9, 10, 11, making the improper fraction 11 quarters. In the final example, we've got 5 whole ones, but each of those whole ones are split into 6. So 1 whole one is 6 sixths. Can you pause the video and work it out and check with me in just a moment that you've got the correct answer? Good job if you've just worked that out. It should be 5 times 6, because each whole one is 6 sixths. So that's 6, 12, 18, 24, 30, plus an extra 5 would give you 35 sixths, still split into 6 equal pieces. Again, in your class dojo, I've put a link to help you to convert between those if you're a little bit stuck, because you will need those for the rest of the lesson. Okay, so today we're adding two mixed numbers. Now in our first example here, we've got 1 and 2/6 added to 2 1/4. Now we can quite easily add the 1 and the 2 equals 3. We've also got 2/6 and 1/4. So to add those together, we need to make sure they have the same denominator. The denominator we've chosen here is 12. I've chosen 12 because it's in the 6 times table and it's in the 4 times table. 6, 12, 4, 8, 12. It's in both the 6 times table and the 4 times table. So let's convert this 6 into 12ths. I times the 6 by 2 to make 12, so I need to times the 2 by 2 to make 4. So my numerator there will be 4. And then with the quarters here, 4, 8, 12, I multiplied by 3, so I need to multiply 1 by 3. 1 times 3 is 3. Now I can add them together. I've got 1 add 2 is 3. And then I've got 4 twelfths add 3 twelfths. 4, 5, 6, 7, 7 twelfths. In this example, I don't need to mess around between mixed and improper fractions because this is a proper fraction. The numerator 7 is smaller than the denominator 12. Let's look at our next. So here we've got 2 1/2 plus 3 2/5. Okay, it's easy enough to do 2 add 3. 2 add 3 is 5. That's nice and easy. We've got a half add a fifth here. Sorry, 2/5 here. So we need to turn those into having the same denominator. And I've chosen to turn them into tenths. I've chosen that because in the 2 times table there is 10, and 10 is also in the 5 times table. Now let's convert the half first of all into tenths. 2, 4, 6, 8, 10. I multiplied it by 5, so I need to multiply the 1 by 5. 1 times 5 is 5. Then I need to change the 2/5 into tenths. 5, 10. I multiplied the 5 by 2. So I need to multiply the 2 by 2. 2 times 2 is 4. Now I can add it together again. 2 plus 3 equals 5. 5 plus 4 equals 9. So I've got 5 whole ones and 9 tenths. And again, it's a nice proper fraction here, so we're absolutely fine to leave this as a mixed number. We don't need to do any converting. My final teach it for it's your turn to practice it, so listen carefully. We've got sixths and fifths to add together. They need to have the same denominator. The number that's in the 6 times table and in the 5 times table is the number 30. So a common multiple of both is 30. 6, 12, 18, 24, 30. Times it by 5, so I need to times the 1 by 5. 1 times 5 is 5. Next up, 5 times table here. 5, 10, 15, 20, 25, 30, multiplied by 6. So I need to do 2 times 6. 2 times 6 is 12. Add them together. 2 plus 3 is 5. And then I've got 12 plus 5, 12, 13, 14, 15, 16, 17. Give me 17 30ths. Okay. Again, it's a nice proper fraction, makes a perfect mixed number. I don't need to do any converting for that one. Here's your practice it. So pause the video now, practice one at a time, and I'll reveal the answers one at a time in just a moment. Okay, so the answer for the first one, I would convert them both into sixths, and my answer is 2 and 3/6. If you turned them into twelfths, it would be 2 and 6 twelfths. Try the next one. The answer for the next one is 2 and 5/8. I converted them both into eighths. If you converted them into sixteenths, the answer would be 2 and 10/16. Okay, have a go at number 3. Okay, for number 3, we'll convert them both into tenths, giving us the answer of 3 and 3/10. Just check your answers here. Make sure that you're always adding these whole numbers. You're not forgetting to add these whole numbers into your answers. And have a go at the final example. And the answer to the final example is 4 and 5/6. Again, just double checking you've come up with a mixed answer there and you haven't forgotten to add the whole numbers on. If you've got all of those correct, that's fantastic. You can move on to the do it. So can you complete the do it? In this one, there is one example where you'll have to think about changing the answer at the end and converting one of the improper fractions into a mixed number. So if you need to do that, go back to the beginning and remember how to change them. Pause the video now and complete your do it. Excellent job. Let's have a look what Colin's done wrong for his twist it. So Colin thinks that 1 1/4 plus 2 2/5 equals 4 3/20. What step has he forgotten? So work it out yourselves and figure out what he's forgotten. And then always, sometimes, never true, when adding mixed numbers with different denominators, you change the mixed numbers to improper fractions before adding. So in all of these examples, did we change those mixed numbers into improper fractions before we added them? And if we didn't, could you do that? Would it still work? Think carefully about that and have a go at it before you answer it. Okay, pause the video and complete your do it and twist it. Sorry, your twist it and solve it. Excellent, good job.